Welcome to Taxonomy Online Mathematics. In this video, we are going to have the concept of logarithm explained. If you are new here, please consider subscribing to the channel to enjoy more of my videos. So we are saying that logarithm, we are done with the indices. Indices and logarithms, we can convert from logarithm to indices and indices also into what? Logarithms. We are saying that logarithm is just, or logarithm of a number to a given base is the exponent to which the base must be raised in order to give us the number. Thus, if we have y equals to a exponent x, we are saying that this is the base in terms of indices. This is going to be the base, the exponent, this is a number which we break into this power. Then we can say that by the definition of logarithm, then you're going to say the log of the number, which number? This, to the base a is equals to what? X. So logarithm of a number to a given base is what? The exponent to which the base must be raised in order to give us the number. So it is the exponent to the base. So we can see that from indices to logarithm, the base remain the same. If I'm converting from indices to logarithm, from logarithm to indices, the base in the two equations, if I were to label this equation 1 and this equation 2, the bases are going to be the same. So if, for example, you have, let's say, 16 equals to 4 exponent 2, as in indices, and we are asked to write this back into logarithm, the base here is what? 4. So it means our logarithm is also going to be in base 4. But this will be the number. The number, because the base must be raised to an exponent in order to give us the number. So this is going to be log 16 to the base 4 is equals to what? 2. Log 16, which is a number, to the base 4 is equals to the exponent. So in logarithm, the exponent is a number that we are looking for when we operate the logarithm to its base. This is what they are going to get. In indices, this is the number of times that the base must multiply in order to give us what? Our number. So 4, it will be multiplied 2 times to give us 16. So this is the convection between the indices and what? Logarithm. So if, for example, I'm giving this to find, per the understanding from here is that this is log 27 to the base 3. We need the answer. We need this 2, or better still, this 2. The exponent to which the base, this base must be raised in order to give us what? 27. We need that exponent to which 3 must be raised. So in solving such questions, we know calculator can give us the answer, but we can also solve. We are going to let this. So you let the question given to you equals to a variable. Let the question given to you equals to a variable. So in this case, this is the exponent here. This is the exponent that we are looking for. So we can say that 3 exponent y is supposed to give us what? 27. So I will have 3 exponent y equals what? 27. And this is in equation 1. 27 equals to the base exponent, the x. So this is our 27 equals to the base exponent, our x, which is now what? Y. So I believe transferring from logarithm into indices, we can easily get the answer. As in this case, we are going to make sure we break 27 also to what? Base 3. So that become 3 exponent y equals to 3 exponent what? 3. You know, 3 times 3 times 3 give us what? 27. Alright, so per the law of indices, if you have an equation whereby the base are the same, we take the what? Exponent. So in this case, our y is going to be answer 3. It is by chance that we are having so many 3 in this question. But let's see if we can take another question that may not necessarily have the 3 or the bases being multiplied. So we can say find the value we are asked to find the value of what? Log 16 base 2. So to get the value of this, as in this case, the value of all of this is going to be 3 because the whole of this will let you be y. So if y is replaced with 3, it means the value of this is just equals to 3. Alright, so I think to write it, therefore, your log 27 base 3 is just what? 3. So in this case, we are going to let this also equals to what? X. If the whole of this is equals to x, then I'll be saying that 2 exponent the x to give me what? 16. Now we are moving from logarithm back into indices. So what do? We look at the base, which is 2, and see whether we can also express 16 to a base and an exponent. The base will be 2 anyway. And that will mean if you are multiplying 2, how many times will you multiply in order to arrive at what? 16. So if I have 2 times 2 will give us 4. 4 to 8. 8 to 16. Meaning we are having 2 multiply itself 4 times. So our question or equation still remain this as 2 exponents what? 4. So per the law, if the base are the same, we take what? The exponent. So it implies that our x is just what? The value of 4. Therefore, log 16 to the base 2 is just what? 4. I believe you get the concept, the transition from logarithm to indices and indices back into what? Logarithm. So that simply means that if you are also giving, let's say you are giving this, you are giving this to write back into indices, or convert this or write this in indices form or in an exponential indices form. Don't forget that this will just be translated as, since the base are the same, we take the number as the exponent equals to what? 8. So vice versa, we can convert from log to indices and indices to logarithm. I believe that aspect is clear. Good. So let's say we have this. We have to find the value of log 1 over 125 to the base what? X. Now, in all that we were doing, we make sure that the base is always greater than what? 1. The base is always greater than what? 0, sorry. It should be greater than 0, meaning we don't have a negative base. Now, anytime you have the log which is having a number between 0 and 1, that is in a fraction. This fraction is what? A proper fraction. It means that your answer is going to be negative. The answer you are going to arrive at. You see, all that we did so far, the numbers we have as the number of the log is positive. As in a number greater than what? 0. But also it is more than what? 1. Therefore, our answer we arrive at is always what? A positive answer. But in the case whereby we have this to be a fraction, we have to expect our answer to be negative. How? Let's check. So here we let our log 1 over 125 base 5 equals what? K. If that is the case, right away we know that this is the base of both the log and the indices. This becomes the exponent. So we're going to have 5 exponent k equals to 1 over 125. So this is now in indices. We know that if we have 1 over a number, we can have the reciprocal, whereby we get the negative exponent. So this is going to be 5 exponent k equals to 125 to the exponent what? 1. In order to clear a fraction, it becomes a power of negative 1. The base is 5. We can also convert this to base 5. So this is going to be 5 times 5 times 5. How many times? We'll give her 125. And I believe that will be 3 times. So 5 exponent k equals to 5 exponent 3. That produces 125. But there is already a power of what? Minus 1. So we let that be there. So in that, our 5 exponent k is going to be 5 exponent minus 3. Property of indices. A power to the power raised to a power, the powers will multiply. So this will give us negative 3. So per the law, since this is the same, our k is going to be minus what? 3. Therefore, log 1 over 125 base 5 is just what? Minus 3. As I said earlier on, when the number is between 0 and 1, that is the fraction, we are going to get our answer to be a negative. So the exponent we are having is negative. I believe this concept is understood. Alright, so that will be for so here we have to find the value of log 0.001. 0.0001 to the base what? 10. We want to find out what would this equals to. Don't forget that this is also a number between 0 and 1. Therefore, our answer is expected to be negative. But I'll leave it here. Try and see if you can get the answer to that. Then you can share your answer with me in the comment section. If you are new, please consider subscribing. If you like this video as in find it educative, please like, share with your learning colleague, and don't forget to leave a comment as we get interactive. Thank you for watching. Bye.